Yeah, so a couple of people can see my screen, which is a good one. All right, so let's begin this meeting. I welcome you all to this machine learning Python course brought to you by Alo-Fusion Limited. And then in the next 2 weeks, the idea is to bring you all from being a fresher in this field to being someone comfortable in building machine learning models. I'm someone that's passionate about machine learning. And then I have built a couple of models and also have in the past written articles on different topics in this concept. So I am a data scientist, a machine learning enthusiast, I'm a freelancer, and I'm a content writer. My name is David Obembe, and welcome to this machine learning course. Okay, so I will begin straight away. But first off, let me point out that this will be an interactive session. So from time to time, I would ask questions, and then because of course I don't want this place to be rowdy, we'll use the chat section to respond. But I'll be asking a couple of questions. I'll be asking for feedbacks from you, and then it's my hope that we'll have a wonderful time together, and then we'll all have a great time of learning, right? So before we go further, I think it is important to talk about artificial intelligence, because artificial intelligence is like the umbrella that encapsulates machine learning. So while the end goal is to talk about how to build machine learning models in this course, I think it would be very good to talk about artificial intelligence and what it's about. So as you can see from the screen, a machine that can mimic human behavior, okay, is called an artificially intelligent machine. So artificial intelligence is just the process of any machine to mimic human behavior. And that's basically done by learning from data and then afterwards trying to achieve some set goals. All right, so there are some keywords here. And the major keyword I would like you to take home is a machine that tries to mimic human behavior. So that's the idea of artificial intelligence, basically. We all have our behaviors, we can do things. So as humans, if you see a cup, for instance, we can say, oh, this is a cup. If you see a cat, we can say, oh, this is a cat. So the idea of having artificial intelligence is to be able to build systems or build machines that can also do these tasks that we do. All right, that's the end goal of artificial intelligence. And then I would like to talk about the Turing test, because that's what is like a litmus test to check whether a system is artificially intelligent. So I don't know, has anybody heard of Alan Turing? So let me know, have you heard of Alan Turing? Have you heard that name before? Alan Turing, let me see if you've heard of the name. Okay, yeah, so Alan Turing was a computer scientist, and then he was one of the persons that you can attribute the victory of World War II to, okay? So what he did was that he built a machine, and then that machine could read German Enigma. So the Germans communicate through encrypted codes. So it was difficult for the US military to read those codes. But Alan Turing created a computer that could read that code. And so Alan Turing is a major voice when it comes to artificial intelligence. In fact, you can call him one of the pioneers of artificial intelligence. Sorry, are you guys getting notification noise? Are you getting that? Let me know if you are getting any notification noise. So I'll just take off my WhatsApp. Are you getting any noise? Oh, okay. That's great. So Rachel says she's not getting. Okay, so okay, it wasn't loud. Okay, great. I think most people are not disturbed by the noise. So I connected my WhatsApp to my laptop and I'm getting some WhatsApp messages. So that's the cause. All right, so sorry about that. So let's proceed. When you talk about artificial intelligence, one of the pioneers is Alan Turing. And then Alan Turing gave a test to show whether a machine is artificially intelligent. So, and that test is called the Turing test. And that's what you can see in this diagram here. What Turing says is that if you have a system, if you have two systems, for instance, as you can see here in A and B, so A is a machine and B is human. So C is interacting with both A and B, all right? So what the Turing test says is that after a while, if C cannot differentiate whether A is a machine or human, it means that A is an artificially intelligent machine, all right? So that's the Turing test. So it's just to check, it's like a litmus test to check whether or not, oh my God, okay. Okay, some people are waiting. Let me admit all. All right, so the Turing test is a test to just check whether you have the system to be artificially intelligent. And that's, the test basically says that once you can fool a human, once any machine can fool a human to think that is also human, it means that that system is artificially intelligent. I don't know if I made sense, or I should come over again. The Turing test says that if, for instance, I'm interacting with a machine, right? After a while, and I don't know this is a machine. So you can see there's a blockage here between, of course, the human and the machine. So if after a while, I cannot differentiate, right, which is human and which is the machine, it means that that machine is artificially intelligent. So the Turing test just says that any machine that can fool humans to think that it's also human, it means that that system or that machine is an artificially intelligent machine. All right. So move to the next slide. Okay, so there are two approaches to AI, and then I think it's very important to talk about them. You can have what we call strong AI, and then you can have what we call weak AI. All right, so when you have strong AI, it means that the system can do all tasks. It can perform all tasks. The system is designed to perform all tasks. While in contrast, the weak AI is designed to perform just one task. So if I have a system that will differentiate whether there's a dog or a cat, it means that that's a weak AI, right? But a system that can do all things, okay? A system that can do all things, that's classified under strong AI. Another way to differentiate between a strong AI and then a weak AI is that a strong AI has cognitive abilities. And I think that's what actually differentiates humans from robots, because as humans, we think, we have a brain, and then we can reason, right? We have emotions, we have all those things. So a strong AI is any system that has its own mind. So it is not programmed to do any particular thing. It can do stuff out of the box, and then do things that it was not programmed to do. All right. So that's a strong AI. But a weak AI is programmed to do one thing. Okay. So if I build a system, for instance, and then that system was programmed to, like I said earlier on, differentiate between a cat and a dog, of course, that's a weak AI. So a strong AI is called, or can also be called, artificial general intelligence. And then the weak AI can also be called narrow artificial intelligence. All right, so I think is a good thing to know the differences between the two approaches to AI. Before I go any further, I want to ask a question. Okay, people say that yes, AI will be the end of humans. People will say we take over our jobs, take over everything, and all those stuff. And I think when they talk about that, they're talking about strong AI. So I want to ask, do you think strong AI is in existence now? Do you think you have strong AI right now at work in our present day and time? So let me get a response. Do you think we have strong AI right now already at work? Okay, so Olamide said yes, we do. Tumlola Podju said yes, I think we do. A lot of people are saying yes, but I think the first response was no, right? Let me scroll up and see. Yeah, no, not yet. That was from Olade. Okay, so I think she's the only one there saying no. The others are saying yes. Okay, a couple of people also are saying no. Okay. Okay, should I get more response? Yes, I think so. Yeah. Latsunji, okay. Damian, no. Kamaluddin, no. Hamid, no. Okay, I'm not sure. All right, well, so I think if you ask me, well, not about me anyway, right now we actually do not have strong AI yet. We do not have strong AI yet. And the truth is that we are not likely to have strong AI in the next 50 years or so, because really the AI systems we have are programmed to do just one thing, or are programmed to do a specific thing. They can't do things outside of what they are programmed to do. Or they don't have the mind on their own. Yes, they can think, but they are think within a limit. Okay, so I found a poster here, and then I don't know the picture to the left. Does anybody know this movie? The picture to the left, because it was a movie I saw while growing up, and then it really stuck with me. Even though I've not seen it in a long time, when I was preparing my slide, I just remember the movie and then I put the poster here. So has anybody seen this movie, or does anybody know what this movie is? Um, um, okay, has anybody seen this movie? Okay, so a couple of people are waiting. Oh my God, you guys don't see movies? You guys don't see movies? Okay. I'm surprised you guys have not seen it movie, but I saw the movie while growing up. This was an Indian movie. I think it was released in 2010. It's called Robo. Um, and then what happened was that these scientists built a robot, and then that robot had a mind of its own. And then the robot had emotions. Although these scientists had the option of removing that part, okay, removing its emotion. The robot was behaving very well. But the scientists found out that there are some things the robots, does that it doesn't just make sense. But it was basically because that was how it was programmed. So it had no emotions and it was just doing things in a straightjacket way. So because of that, they added that emotion part to the robots. And then what happened was that the robot fell in love with the scientist's girlfriend, and then the robot thought the scientist didn't like him and all those stuff. And then he was head over ears over the lady. And then that caused a rift between the robots and the his master, because really he now had a mind of his own. It could not how will I put it? It could think outside the box and it could do things on its own. So there was this rival scientist who has also been working on creating robots with emotions, and then he didn't get it. So he influenced this guy. Okay, the name of this guy is called Chitty, if I remember the character's name. Yeah, Chitty, that was his name. And then over, okay, the comments are killing me right now. Okay, so said, you have to bring the Nigerian part of it here. It's okay. All right, so So what happened was that this guy became very disruptive, and then he was influenced to do a lot of things, and then he even created other robots to do a lot of, cause a lot of havoc and destructions. And then it wasn't just a good thing in the end of it. I've forgotten how the movie ended, but I knew that before they brought this guy to order. In fact, his master had to destroy him, basically. He had to find a way of destroying him. And that was because this robot had a mind of its own. So what I'm trying to bring out is that we don't have robots that have its own mind, okay? And if we do, it can be very destructive. And that's why we can say the robots or artificial intelligence may be the end of us. But for now, I think we are still good with narrow artificial intelligence. And that's where you have what you can see on your screen, and that's the Google Assistant. So you can say, Google, what's the time? Google do some research and then, produces the time. You can ask all those common questions that Google can answer. But if you say, except you connect, I know there's this Google Home where you can connect Google to your home. If you say Google, switch on the lights, most likely your Google Assistant will not switch on the lights, except you have this Google Home feature where you can connect, Google to home. But all in all, what I'm trying to point out is that even with Google Assistant, it can only do what it has been programmed to do. It can't think outside of the box. It doesn't have its own cognitive ability. Right? So I believe I'm clear with those two. All right. So for now, we are still dealing with weak AI. It's unfortunate they call this weak AI, not strong AI, but yeah, that's what we are working with. But even though it's called weak AI, we have created very powerful machines, which I'll be talking about very shortly. All right. So let's move on to the next slide. Okay, so this is a very important thing to talk about, because really AI is virtually everywhere. I don't know why some lines are showing on my screen. I want to see if I can take them off. Where does that come from? I'm trying to see if I can. Are you guys seeing some red lines? It's kind of annoying me. I want to take them off, but I don't know. Oh yeah, I can. Does anybody know? Yeah, I can take these red lines off. Oh shit. Oh yeah, I know you guys can see it. It's with the whiteboard feature, but I didn't turn that on. So it should not show. Yeah. Okay, annotate. Okay, yeah, I think yeah. I think I got it now. So I'm gonna clear them, right? Clear drawings. Yeah, thank you. All right, so I'm sorry about that. So let's get on. So now, as I was saying, AI is everywhere, basically, whatever you think about. So if you talk about automobiles, right now you have self-driving cars, which I think is a major breakthrough in the AI space recently. You have AI in e-commerce. You have customers, companies now trying to segment customers based on how faithful they are. So you have a customer that continuously buy goods. You have AI systems that can, find a way of segmenting them. So you have this system is segmented. This customer is segmented as a faithful customer, and then this one, okay, is still shaky. It's in between the fence. So you have AI that can do this segmentation, or call them clustering. Hello, guys. I think I lost you guys. Can you see? Can you hear me? Can you see my screen? Okay. I think I was lost for a while. God. Okay. Yeah. That's good. I think. Yeah. So I think that's a good one. So thank you all. I think I'm back. Yeah. I was gone for a while, but it's good to be back. All right, so yeah, so as I was saying, I said AY, e-commerce, you have customer segmentation, right? Social media, where you're typing on Google, you have autocomplete, right? You have, ads, tailored ads. So they use AI systems to know, oh, this kind of person, this kind of ads you will likely see, and all those stuff. So in cybersecurity is a big thing. And then you also need AI to determine whether, right, there's an attack or this is a possible attack. Let me say that. Let me give this research. Norton said that a typical breach, in any company will cost about $3.86 million. So if a system has a breach, for instance, and then you have penetrations, it can cost that company about $3.86 million. So cybersecurity is a big thing. And in fact, I think it's one of the digital skill that we also need to learn, because it will definitely be in demand. You can imagine someone trying to hack GT Bank, for instance. That guy is in money. So GT Bank security cybersecurity team has to be on top of their game to ensure that doesn't happen. Okay, so AY can, did I say AI? AY? AI can determine trends in past bridges. Okay, so you find trends, okay, this is what they do, this is how they do it, and then try to create systems to prevent future breach. Okay, so AI is in cybersecurity, AI is in education. People now use AI to review quizzes, mark exam scripts, all of those routine and repetitive stuff that we do. AI can take over those things and then just augment our workflow, basically make it easier for us to do things better, and then all those stuff. So really, the thing AI would do, AI won't take off our works. It won't generally take off our jobs, but it can replace repetitive tasks. Okay, so if you have something that you are doing repeatedly, it doesn't make any sense continuing to do it. So in those cases, you can have AI systems to take over. While we leave systems that will involve emotions to humans, so system that will involve emotions, empathy, all those kind of stuff. Yeah, AI can take over that. Yes, because like I said, we are still dealing with narrow AI, yes, not general, artificial general intelligence that has their own mind or cognitive ability. So let's move on. So you have AI in education, you have AI in finance and banking. In some other parts of the country, I don't think they give credit cards in Nigeria, but in other parts of the country or in other parts of the world where they do give credit cards, the bank can't just give anybody credit cards. They have to be sure that, oh, this person is a loyal customer, or this person is worthy. Okay, so he's worthy of getting a credit card and he won't default, he won't run away. They call it a churn analysis. So AI can also help in doing that churn analysis in banking and finance and all those stuff. AI can also come in agriculture. It can also be used to detect weeds in plants. It can be used for a lot of stuff. Also plants that has defects or diseases. AI can be used to detect and solve that. Well, in healthcare as well, AI also play a fundamental role as well. You can have AI systems that can detect diseases just by looking at the picture, or looking at a picture of a cell, and detect whether or not this person has malaria, this person has whatever disease. So AI is coming in big time in terms of health sector. So like I was saying, AI is basically everywhere. You can go on and on and on and on. If you check anything, you can just type on Google, whatever field you are, you can type AI in this field. You will find some results, you will find some applications of AI. So AI is basically everywhere, and it will definitely continue to improve. And then we'll still talk about the reason for this explosive growth later. But let's dwell on AI on healthcare for a while and talk about one of the major breakthroughs you have in healthcare, and that's the AlphaFold experiment. This was an experiment done by Google Google AlphaFold team, and then what happened was that um, first off, let me give you a background to what this is about. Basically, whatever we do in the body, whatever our body do, is attributed to the shape of proteins in our body. Okay, so if, for instance, we are trying to pick up something, our muscle is moving, it is attributed to the shape, okay, of the protein. So there are billions of proteins, just like cells, okay? So there are billions of proteins in our body. And then it is those proteins, the function of the proteins determines how we move, okay? So how the protein rotates, how the protein folds, how the protein change shape is what determines what we do. Okay, so it goes down to our antibodies. Our antibodies, the cells in our antibodies react to diseases. Okay, how we actually do things basically. So everything we do, it boils down to the position and shape and folding of a protein. So a protein can have, for instance, this shape to the left, and then maybe, for instance, you are changing your position. So maybe you were seated and then you wanted to stand up. Now, while standing, some proteins won't have that exact position again. It will change. So bottom line is that everything we do changes the shape of the protein. So it's the protein shape that determines our actions, how our body reacts to diseases and all. So the thing is, once they can predict how a protein will fold or the exact shape and angle of a protein per time, it's been a major breakthrough, especially in the times of diseases. And this has been a problem for the past 50 years. But what this Google AlphaFold team did was to create a machine learning model that can predict the folding or the shape of any protein per time. Okay, so how can this help us? It therefore means that we can build our immune system to react better to diseases. So if you know that, oh, this is how this particular protein would fold when the disease is coming, we can create another protein shape that would change the position of that that would counter the effects of the disease. So it can help a lot when it comes to building our immune systems. Since diseases are actually linked to the shape of proteins, we can understand how diseases are, we can understand them better. And then basically we can also, based on the shape, we can develop drugs that we know also work with the exact shape of the proteins per time. So it's a major breakthrough. We got an experiment, as you can see, of about 90.7%. This was about 93.3%, and then which was actually unprecedented. It's a major breakthrough. It's a major breakthrough. In fact, since we have cells that can eat up, oil, fat, and oil in our body, they can, because of that, create proteins that would, manage pollutants in the air. So in industries where they have a lot of waste in terms of fat, in terms of air pollution, or they can also create proteins, okay, based on the shape right now, that would do those functions of absorbing and then taking out biodegradables, right? So I just wanted to talk about this experiment because it's one of the major breakthroughs that happened last year. This was an experiment that they got this breakthrough last year, and then it was all over the news. So I think you can read about this further, and then you get further experiment, further information. So let's get going. Okay, so I said I was going to talk about why we have this explosive growth. We said that AI is everywhere, whatever sector you are, they will definitely have one application or the other. So the question you ask yourself is, what is the cause of this explosive growth? The first one is the massive data, okay, and then by extension, I would say is the advent of the internet or social media. So before now, we get data by mostly research, questionnaires, all those kind of stuff. But right now, we get data every second. If you click on a link, the website has a backend to store your data. If you register for a course, you have your data. If you, whatever you do, if you spend some time on WhatsApp or Facebook or Twitter or YouTube, these guys are getting data every single time. If you go to any particular website, these guys are getting data. So the massive data we have right now is what has caused the explosive growth we have experienced in artificial intelligence or machine learning, right? And the second thing that also can be attributed to this explosive growth we've gotten is the fact that we have faster processors. Faster processors. So to my left here, this is the IBM 7090. Now, in 1956, there was a conference called the Dartmouth Conference. That was the conference where artificial intelligence was first mentioned. I didn't just want to talk about the history of artificial intelligence, but if you read about the history, you definitely hear about this Dartmouth conference. So in this conference, a lot of AI enthusiasts and all of them, including Alan Turing, were present to discuss the way forward and how to better this field. This was the best computer by that time. That's what I want to point out. So in 1956, the IBM 790 was the fastest computer by that time. Now look at how big this computer is. You can see how big this computer is. It's filled up a whole room. And then with this massive size, this computer can process 200,000 operations in 1 second. All right, so this IBM 790 can process about 200,000 operations. So if a human were to do what this guy is doing in 1 second, a human would take about 55 hours to do the same job that this machine will do in 1 second. So for all intents and purposes, this was a very fantastic machine. It was a great one, and then it was just the best in town. But I think it is without mention that this is the iPhone 12, right? Who doesn't know the iPhone 12? Here's the iPhone 12. But before we get to the iPhone 12, in 2010, when the first iPhone was released, that could perform about 400 million operations. So this guy was released in 1957. It could perform 200,000 operations. The first iPhone was released in, I think, 2010, right? I'm not sure. Okay, I think it was 2007. Well, whatever year. You guys can do your research. So I think it was 2007. The first iPhone was released, and it can do about 400 million operations in a second. Right? That was the first iPhone. But now the iPhone 12, according to Google, can do about 11 trillion operations in a second. Now, what does this mean? It means that once you have massive data and you have a fast processor to process that data, you can do a lot of stuff. You are not limited. Okay, you're not. If you guys, when we get to, I don't know if you're going to get to that in this course, but if we talk about convolutional neural network and talk about the ImageNet competition, you can read about the ImageNet competition because it's kind of the major breakthrough again that happened when it comes to computer vision and all of those stuff. So if you can't read about ImageNet competition, it was a competition that happened from 2010, to I think 2017, and then what happened was that there was a data set about, I think 10 million data sets with about 1,000 classes. So it was an open competition where people can, create data sets to classify those images. So they had about 100 classes, so different things, dog, cats, anything. So people were, releasing machine learning models that could classify them. And then what happened was that people were using machines that had, 2 processors. So if you look at the AlexNet model, for instance, the AlexNet model used 2 computers to train this model. So what am I pointing out? Even with the fast network, AlexNet still needed 2 computers to train its model, right? So what the point is, with massive data sets, you need fast processors. And since these 2 things are in place, therefore can expect a limitless explosion in machine learning. All right. So I think I'm clear with this. Let's move on to the next slide. Okay. So I think we've talked about artificial intelligence to a very large extent. And then one thing keep on popping up, and that is data. Well, the truth is machine learning or artificial intelligence basically is hinged on data. Okay. So if you're asking me to build a machine learning model whatsoever, the first thing I ask you is data. If you can't give me data, we're out of business. All right. So when we talk about artificial intelligence, we have to talk about data. We have to talk about data. It's completely important. And then when you talk about data, there's an umbrella that encapsulates the idea of getting insight from data. And that is called data science. Okay, data science is a very broad field. If you ask me, I would say data analysis is under data engineering is under data science. All of those other many fields you see, they are all under data science, because data science is basically the art of getting insight from data and then making predictions. Okay, so that's data science. And I think if we have to talk about data science if we are talking about artificial intelligence. Now, this Venn diagram, as you can see on your screen, is a Venn diagram that explains the 3 key components that you will need in data science. And that's first, math and statistics. Second, hacking skills. Well, don't be too scared. I'm not talking about raw hacking. It's also called programming skills. So you need programming skills. And then you need some domain expertise. So let me just talk about each of these stuff one after the other. So the first thing here is math and statistics. So, well, I know you all don't like to hear this because some people don't have good foundation in math, but to some extent, you will need some background mathematics when talking about data science. At least you need linear algebra. You need to some extent calculus. I'm sorry, I'm sure that's scared a lot of people already because differentiation, integration, I'm sorry, it has a lot of application when it comes to optimization of a neural network. So if we talk about Adam optimizers, all of those RMS prop, all those things we may talk about later in this course. We're talking about calculus basically, because that's how the system tries to improve by differentiating and differentiating basically. So yeah, to some extent, you need maths and statistics here. But in this course, I'm not going to focus on the maths and statistics part. I'm not really going to go in depth into that. I'm just going to talk about how to apply this stuff so people don't get thrown away. Okay, so you also need programming skills. So they call it hacking skill. Yeah, hacking. So it's called programming skills. Okay, so you need to write algorithms. You need to write algorithms that will help you do these machine learning classifications or whatever you're doing. So yeah, you need programming skills. And then finally, you need some domain knowledge or some domain expertise. And that means that you really can't work with any data without having an idea of what you're dealing with. Okay, you need to have at least some extent what the data is about. Okay, so why do you guys come in late now? I mean, I don't want to be distracted, okay? I've admitted everybody. All right, so let's press on. So like as I was saying, you will need some domain knowledge. For instance, if I'm working on a data in a company that deal with agricultural produce, I can't say because I'm a data scientist, what's my business with getting to know what seeds are and all. It doesn't make any sense because really the data you'll be working on may deal with different species of seeds or different kinds of seeds. And then you must have some domain knowledge to be able to wrangle that data well, clean the data well, and build a machine learning model. So yeah, in this intersection of these 2 things, you have some other things. So when you have programming skills and maths without some domain expertise, you can just call that machine learning. Because in machine learning, you may not need to know the features like that. All you can just do is to pass in your model into some algorithm, or the rest you can do is to build an algorithm. Let me not say you pass some model. So when you have maths and programming, you can build machine learning model. For instance, a simple linear regression model just works with the principle of M is equals to, right? What's the formula? Oh my God, I've forgotten my maths. Y is equals to mx plus b, right? That's the basic formula of linear regression. So that's how to build a linear regression model. So if you can, in fact, with that, you can basically build a linear regression model because you know M is equals to what? Dy dx, right? And then C is just if you take you make C the subject of the formula in y is equals to mx plus b, you will get what C is. Ym is what? Dy dx. So with that, you can build a linear regression model already. So what am I saying? If you have some programming skills and you know some maths, you can build machine learning model, and that's why it's called machine learning. All right. So with the intersection of maths and domain expertise, that's just a research. Okay. So when you have maths and you know the domain, it's for the research people do, market research, all of those stuff. Because once you just have the domain expertise, you don't need programming or whatsoever. With your maths, you can do some research, or you can call that data analysis. All right. When you have hacking skill with domain expertise, it's called the danger zone, which is scary for me. Even when I saw this at first, for me, what the fuck? What is danger? What is the meaning of danger zone? But basically, what that means is that it is not the best place to be when you have the hacking skills and domain knowledge without maths and statistics. Okay, because you will need it to some extent, right? You may not need it heavily, but you would need it. So when you're dealing with just hacking or programming skills with some domain knowledge, you will build nice models, but it may not be the best because you will need math and statistics to do a very fantastic job. And that's why it is called danger zone, okay? That's why it is called danger zone. Okay, so then as I said earlier on, data science is the intersection of all three fields. So these are like the three major components of data science. You need maths, you need programming, and then you need some domain knowledge. Okay, just keep on admitting guys that are just coming in. I hope you guys have not missed a lot. So I move on. Okay, so I think one of the confusions we have basically is to know what is data science, what is data analysis. Well, let me just use this opportunity to clarify that, because in fact, I think some people have the idea that they are coming to teach data analysis here, but that's not what I'm going to dwell on. We are going to teach data science here. So first thing is that data science focus on finding patterns, correlations, and creating model. All right, so that's the idea of data science. If you have the data, raw data, whatsoever, what we just want to care about is that find hidden patterns, okay? Find hidden patterns, find correlations between features, and then just build models based on those things. Build models that can do something, okay? That's what data science care about. When data analysis, what you're doing is that you focus on a particular KPI, and then you create reports. Okay, how does this thing affect this? All right, so if you have, for instance, a data that shows how your customer buys stuff. Okay, so you have quantity, for instance, you have the kind of products he buys, you have the time of purchase, you have the price of the product, and all of those stuff. You can focus on, okay, how does the price or how does the time of the month affect purchase of customers? Okay, so your KPI in that particular time is, okay, maybe time or price or whatsoever. So you create reports based on that. Right. So data science is open to new questions. So really in data science, you don't really like, okay, you can have questions, existing questions, but you're open-ended. You're open to new discoveries and new things. But in data analysis, all you do is that you have some question in mind and you hope to answer that question with the data. So a company can employ you and say, oh, why is our price, or why is the price of this particular product always dropping during this particular time? Okay, so you can now use data analysis tools to find solutions to your problems. Okay, but the idea is that you have some answers, some questions in mind, and it is your hope that with data you would be able to answer those questions. Okay, so now data analysis is predictive, yeah, prescriptive, preventive. Okay, so the idea is data, you're trying to predict stuff. Okay, it's futuristic. So you have data past, that's historical data, and they are trying to predict the future. Okay, that's the idea of data science. While data analysis is retrospective. So in that case, you're looking at the past. Oh, this happened in our data. Why is this happening? Okay, and then it's descriptive. So you're also describing the data, trying to make it understandable and share insights from that data. Okay, so data science, of course, require programming skills. Why data analysis may not require programming skills? You can do data analysis with tools like Power BI, Tableau, SPSS, Excel, all those stuff. You really don't need programming skills to do that. But when it comes to data science, you're making predictions. You need to build models, and then you may need programming skills, for instance, Python, Scala, R, and all of this stuff. Yeah, so let's move faster because I don't know if this meeting will be capped at 1 hour. Okay, so this is a very important diagram, and it's basically the life cycle of a data scientist. Okay, so the first thing that will happen is that you first, of course, understand what you're dealing with. So you have a problem, you understand the business you're dealing with. I want to know whether this customer or I want to know whether this mail is spam or not. Okay, that's my business. That's what this company wants us to do. All right. So that's your business understanding. Then you need to collect data. Like I said, without data, you're out of business when it comes to machine learning. So data is like the key in building any machine learning model. So you need to collect data. Collect the data, collect a lot of data or a lot of mails and know whether they are spam or spam. Okay. So you collect a lot of data, label data, collect it. And then after that, you prepare your data because when you're collecting data, it won't be in a clean form. There may be missing data, there may be repetitive data, and there can be invalid values, invalid numbers or imputations, for instance. If I'm asking you, what is your age? And then in the age column, you're seeing negative number. Does that make any sense? Okay, I think you guys should chat a little. So does that make any sense? Yes or no? You have a data in your age column, you're seeing negative number. So I'm saying age, and then it's a negative number that's there. Does it make any sense to go on with that? Let me know, yes or no. I'm not getting a response. I hope you guys can hear me. Okay, yeah, we're going to get, okay. So Gracious said, no, it doesn't. Damlola says, no, it doesn't. Esther Ladaponde said, no. Okay, so yeah, that's the thing. Glory so says it doesn't make any sense. Okay. Okay, so yeah, you guys get the point. So it really doesn't make any sense to go with that kind of data. And you don't expect the data to always come in clear form. So you must prepare data, and that involves you sanitizing your data to make sure that it is in a clean form and then best fits for a model. Of course, data creation incorporates a lot of stuff, including feature engineering, feature scaling, and all of the stuff. So we'll get into the nitty-gritty of all of those stuff momentarily. But let's go. The next thing is to do exploratory data analysis. Like I said, data science is like the umbrella of all of these things: data analysis, data engineering, all this kind of stuff. Because in these segments now, you're doing exploratory data analysis. So you're just trying to just check to just see if you can get some insights, you get some things before you build your model, of course. So yeah, that's the idea of exploratory data analysis. It's just the idea of doing data analysis again, putting your data in a clean form and then creating visualizations to see the numbers and all of those kind of stuff. All right, so after that, then you create your model, of course. So there are a lot of libraries to create models. You have scikit-learn. We'll talk about all of that in a couple of moments, but you create your model and then you evaluate the model. Okay, so what you're doing the model evaluation is that you're checking if this model is doing a good job. So for instance, you have a data. It's a good idea to always split it in train and test. So the test will have your answers, okay? Then you train a model based on your test data. Then it's a based on your training data, I beg your pardon. So let me go over it again. You have the data, you split your data into two. You have the training set and you have the testing sets. All right. So when you're training your model, you train your model with the training data. Now, the training data has both the features as well as the answers. Let me not be too scientific or be too technical. So you have the question and the answer. Let me put it that way. So your training data set has the question and the answer. Okay. So you are training the model, all right, based on that. Okay. And then when you're then you can now test the data with the testing data sets. And that testing data set has only the question. It is the model that is expected to give you the answer. Okay. So when the model now spit out the answer, you can now compare the answer with what it was before. Okay. I don't know if I make any sense, but that's the idea of model creation and model evaluation. So you split data into training and testing data sets. Your training data set has both question and answer. When you're evaluating, or when you're fixing your data, you do it on the test data set without the answers. So the model is expected to spit out the answers, and then you now compare the answers from the model with the original answers from the data. All right, so that's data evaluation. So if it's good enough, if your model is doing a great job, you can now deploy your model. So you can pass it into perhaps an application or a website or whatever. You can pass the model and then it's fit for the end user. But that doesn't stop there. You also have to continue to check your model and see whether it's doing a great job, even in deployments. Okay. So if your model is not doing well again, you must understand the business and then start collecting that data or refine the data a little bit. And then the cycle continues. All right. The cycle continues. So this is the life cycle of a data scientist, and I am hoping that by the end of this tutorial, we'll go over this life cycle, hopefully, from data collection to deployments. That deployment, let's see how it goes. But yeah, we can definitely do that, at least with Oracle and AWS, Google Cloud Platform, and Microsoft Azure. These are like the deployment services you have. Employ one of them, most likely Oracle, because it is free to deploy one of the models we built. But let's see how it goes, because you may need some technical, you may need some knowledge of website development. So, which of course I don't want to go into. But even if you don't deploy the model, at least to get to the stage of evaluating the model and seeing how our model performs. All right. Okay, so we press on. Okay. All right. So let me go back to AI again, because like I said, AI is the umbrella of all these things. And then when you're talking about machine learning, or when you're talking about machine learning, you must talk about AI. And then there are two key fields in this AI, or subfields, like I would say here, and that's machine learning and deep learning. Now, machine learning is basically the idea that a machine learns from a data without being explicitly programmed. Okay, so so that's the idea of machine learning. So if I give a data, say for instance, I tell you, okay, when you have 2, output 4. When you have 4, output 6, output 8. When you have 6, output 12. When you have 12, output 24. Okay, so if you're the machine now and I give you a number like 50, what would you output? Let me ask you that question. Now, I train the model with the data. Let me repeat myself. I train the model with the data that whenever it is given 2 as an input, it should output 4. When it is given 10, it should output 20. When it is given 5, it should output 10. When it's given 12, it should output 24. If I tell the model, or I pass in the model now, say 18. Okay, let me not use a tough number. let me pass in the model 20, for instance. What do you think the machine should output? Okay, so if I say 20, what do you think the machine should output? Okay, that's 40. And I think it makes a lot of sense, because over time, the machine was trained to double the number. All right. Over time, it was trained to double the number. So even though it wasn't programmed to get input of 20, it knows that when it gets input of 20, it will output 40. Okay, so yeah, that's the idea. That's the idea of machine learning. Okay, when you train a machine based on some data, and then you tell it to do something it wasn't trained to do. All right, so it learns over time, and then it can create fantastic results with that. This is a more technical definition, but I put this in the slide because it's important, because these are three key terms that you will need to talk about. And that's the fact that a program is set to learn from an experience E with respect to some task T and some performance P. If its performance on C, as measured by P, improves with experience E. I know a lot of technical stuff is ongoing there, but let me break it down for you. Let me unpack that thing. The idea is that I'm going to break it down with an illustration. Okay, so let's say I have okay. Let me use that same example I give. When I gave it, for instance, I gave it 20. Now, the machine is expected to output 40, right? Now, the task in this case is to double the number, all right? The performance is the result, so the performance is 40. Now, the experience is how many times it has done it, or how long it has been doing it. So let's say in my first instance, instead of outputting 40, the output was 38, all right? What does that mean? It means that this machine was not correct. But that it doesn't end there. The machine now tries to learn again. So say, for instance, at that point you correct it and say, oh, this is 40, and give it another number again to predict. If the machine can improve its error, reduce its error and improve its performance after some experience, so after a given time, right? If the performance can improve, the performance can improve based on the task, it means that that program learns. So let me know if you guys understood what the illustration I just gave, because I think it's a very important one. Do you understand what I said? So say yes if you understood what I said. Okay, Akogo Joseph said yes, Olalade said yes, Aloha said yes, Sorem said yes. Okay, I think I'm good. Yeah, because it's very important. It looks very technical, but it's a very important definition for machine learning. Yeah. So another field to talk about is deep learning. And in that case, we are trying to simulate how the human brain works. I don't know. I really don't think we'll get into deep learning in this course, but it's a very great field to get into, a very fantastic field, deep learning, because in this case we have more control over our model. We can tweak how the model behaves, because in the sense of deep learning we are creating architectures that, yeah, those architectures are called neural network. We are creating architectures that simulate how the brain works. Now the brain works by a cell. The brain has billions of cells, for instance. All right, the brain has billions of cells. Now each of those cells transmit what we call neurons to each other. If transmit those things, and then each neuron processes it and send the outputs to the next cell. That cell processes the output of the previous one and send it to the next cell. Now these guys are connected in a very crazy way. All right, they are connected in a crazy way. So it's a very complex connection between them. And what that does is that over time, the connection between them becomes very stronger, and then they can learn. All right, that's how the brain works basically. It learns over time by having stronger connections between neurons. It's exactly the same way deep learning works. And then we may or may not, most likely would not get into deep learning in this course, but we can work on creating another class for deep learning, which I think it's very important for everybody to understand. Like most big guys now use deep learning to create machine learning models. Okay, they create deep learning architectures because it gives better results, especially when you have massive data. All right, it gives greater results, especially when it comes to natural language processing computer vision, and all of those very interesting applications of AI. All right, so let's make progress. Okay, so I think I just took this here because I wanted you to understand how these guys are overlapping. Now, artificial intelligence is a general field. It's a general field you have. Then under artificial intelligence, you have machine learning. Okay, you have machine learning, and then under machine learning, you have deep learning. So deep learning is under machine learning. It's a kind of machine learning entirely that now uses neural networks. They call it neural networks. So I just need to point that out because it's important to understand where these guys, dwell, and then don't mistake them for each other, right? So yeah, we make progress. Okay, so when it comes to machine learning, they can be divided into two major parts. It should be three, but I put two in this slide, unfortunately. All right, but I'll talk about the third one, although you won't find it on this slide here. Okay, so you have supervised learning, and that means that, like I said, let me just talk in plain English. You have questions and answers, all right? So you have label, okay, which means solutions, okay? So your data, which I'll call questions, your data has labels. So if I say that you should predict, say, the price of any individual, you can have features such as the guy's age, his degree, his experience, the school he went to, and then the label will be yes. What was the question I gave again? Okay, I said his salary, right? Okay, yeah, so the label will be his salary. So again, his features will be, for instance, his name. His name will not be a major feature, but let me put it there. His name, the school he went to, his experience, all those stuff. And then the label will be his salary. Okay, so in that case, that's a supervised learning because the data also has a label, right? But in the case of unsupervised learning, the training data has no label. So in that case, let's say I'm giving that same example, predicting the salary of someone. It means that I'll have his name, his salary, and his name, his school, his experience, where he's working, where he lives, all those stuff. But I won't put his exact salary. So it is the machine's duty to predict the salary randomly. Not randomly, but based on techniques such as clustering and all, it should predict the salary of that person. And that is called that is called unsupervised learning. Okay, that's called unsupervised learning. So the last one, which of course is not in this slide here. Okay, let me just talk about the illustration here. As you can see here, this line demarcates between the red and the blue data, right? Our data points. So it means that if I have a machine learning model now, I don't know if you can see my mouse. Can you see my mouse? And I put the model here. What do you think it should classify, red or blue? Let me get your comments. If I put my mouse here and I ask this model to classify, what do you think it would classify? It should classify because there's some incorrect classification. What do you think? Oh my God, I went to the last slide. What do you think it should classify? Let me hear from you. Red or blue? Red or blue? Okay, red or blue? Not getting a response. Okay, TRM said red, and it said red. Yeah, Esther said red. Armstrong said red. Oluwadam Larry said red. Yeah, Moses said red. Chika says red. Oluwatofumi said red. Yeah, so you guys are correct because of this line here. This line is like, telling you, from here, whatever you see downwards should be red. Whatever you see upward should be blue. Although you can see some incorrect predictions, but it's okay because a machine cannot be 100% correct. Okay, we are not. Our aim is to get 100% accuracy, but it's difficult. It's difficult. So yeah, there's some incorrect predictions that you can see here. But this is supervised learning, right? Because this bounding, this hyperplane here differentiates between the red and the blue line box. Okay, but in this other figure here, there's no line to separate them. You just have points. Assume you can't see this circle. Just assume you can't see the circle. It's the model that creates the circle, okay? But for now, assume you can't see that circle, all right? So, but if the model does saw the data, all of them are gray color. It is now the models to determine that, oh, this is a cluster, all right, of data points. These are that cluster of data points. So the model can call this red and can call this blue. It can call it anything. But in this case, its predictions will be correct because really, of everything here are under a cluster and everything here are under that cluster, okay? And this is an example of unsupervised learning, okay? An example of unsupervised learning. All right, so the last one, which is not on my slide here, is reinforced learning. And in that case, the model learns over time, all right? So now, what you have is a model that is penalized for predicting wrong, and then it learns over time. And then it's a very interesting field because if you read about the AlphaGo project, it's also by Google's DeepMind. You can read about Google's DeepMind project, a very fantastic project they've done over the years. So AlphaGo was a model they did. Go was a game, just like Ludo or Scrabble or whatever. Let me call it Ludo, or you can call it chess, but it's in a more complicated way because you have a lot of moves that you can make. So what year is that? I've forgotten the year. But AlphaGo was designed and it was designed based on, of course, supervised learning. So it predicted a lot of moves, and when it is wrong or when it is not the best move or when it loses, it checks the move it shouldn't have made and then do it all over again. So they trained that model over and over and over and over and over again. And then the major events happened where the best Go player ever, all right? The best Go player ever was placed with AlphaGo, which of course is a computer or an AI-powered machine. And this guy who has never been defeated, right, was defeated 4-1. Okay, so it wasn't a coincidence. They played 5 rounds and then it was defeated 4-1. And then that was the AlphaGo project. Okay, and then it was a very interesting one because it showed how AI can significantly learn over time and defeats even the best humans. All right. So that's supervised learning. You also have semi-supervised learning. You see that sometimes, and that involves you having some labeled part and some part not labeled, all right? And then over time, the model trains itself to label the unlabeled parts. So that's semi-supervised learning, but you most likely not see them. Most of the data you see are supervised and unsupervised learning, right? In this class, we most likely will focus on supervised learning because that's like the foundation of machine learning systems, right? And I think we've come to the end of today's, okay, not yet. All right, so I think this should be my last slide, if I'm not mistaken. So yeah, well, let's talk about some of the tools we need in machine learning because yeah, they are quite important. And then, so first off, we would need, of course, programming languages. The 2 most common programming languages are Python and R. In this class, we use Python, but you can say it's R. But I think Python is a great language to use because they have a fantastic community. It can be used for a lot of things, not just machine learning. So I would, from the next class, we'll talk about, of course, the foundations of Python programming languages. Again, you could also use it for other stuff. So if you decide that machine learning is not so great and then you want to change to maybe web development, you can use machine learning. You can use Python programming language for it. You can use it for hacking. You can use it for game development. You can use it for automation testing, quality assurance, all those stuff. You can use Python for. So Python is a fantastic language, and that's one of the reasons why I learned it, and I also be teaching the language here in this course. So when it comes to machine learning tools, you have TensorFlow. TensorFlow was designed by Google. Fantastic model, fantastic tool for creating machine learning model. You also have scikit-learn. Scikit-learn is a library, a Python library that incorporates most of the most common machine learning models or machine learning algorithms you'll be using, such as logistic regression, linear regression, k-means clustering, um, decision trees, random forests, XGBoost, all those things. Yeah, so you find all of them imputed in sklearn. So you have Weka. I don't really use it, but it's also another tool that you can use to build machine learning models. All right, so when it comes to deep learning models, you can use TensorFlow, but TensorFlow is very complicated. I won't lie to you. I wouldn't say it's complicated, but it is complicated because I've used it. I've tried to build models through TensorFlow and I've used Keras, and then the difference is clear. Okay, when it comes to how complicated these things are, it's always good to use Keras. Keras is an API. If you don't know what an API is just a kind of interface between something and you. Okay, to make life easier for yourself, basically, that's the idea of having an API. So it's a way of accessing a source in a better, how will I put it, in an easier way, so that you don't really get to you get to relate with them better, and then you get to get whatever you want to get easier. So Keras is an API for deep learning. It's an API for TensorFlow. Yeah, you have many APIs. Most of the social media platforms have APIs. So you have YouTube API, you have Google API, you have Twitter API. You know, if you're scraping data from those platforms, it's always good to use their APIs so that you watch the limit, they'll watch the limit of what you're scraping, and then it's also be easier for you. You know, to scrape data from Twitter, for instance, manually, do some crazy stuff. But yeah, so Keras is an API for TensorFlow, used for, of course, creating fantastic deep learning models. You have PyTorch. PyTorch was created by Facebook not too long ago, some years ago, and also used for creating deep learning models. So you have analytical tools, you have Spark, you have Hadoop. Hadoop is for big data. Big data is just a term to illustrate that sometimes you can have data that can never be stored in the system. For instance, if you want to try to store data, Google search engine, it doesn't make any sense to store it, right? So that, for instance, is called big data, right? So you can use Hadoop for that. And then when it comes to visualization, Matplotlib is one of the commonest Python library for visualization. Right? In fact, we use it in this particular class. You also use Seaborn. Seaborn is also used to create very fast visualizations, and then Jupyter Lab, right? Which you won't really use basically, but I can promise you that you use Matplotlib and Seaborn. So we would get into the nitty-gritty of these things soon enough. I'm sure the next class will start with understanding the syntax of Python, the semantics, and all of those stuff. So yeah, that will be it for now. So thank you all for your time, and then please ask me questions. All right, so I'm going to take some questions. I really don't know how many questions I should take, but let's just see how it goes. We'll just play around with that. So the next class, yeah, that's a good one. So the class would hold Mondays, Wednesdays, Fridays, and Saturdays. Okay, and I think this time is great. So it's 8 to 10 p.m. Or 8 to whenever. What's the time now? Let me check. Okay, we didn't use up to 2 hours, and I was thinking I used a lot of time. But next class we may use 2 hours because I want us to cover a lot of grounds in Python. All right. So okay, so let me just scroll. Let me not lose any question. So yeah, the next class will be on Wednesday. Yeah, it should be on Wednesday at the same time. All right. So, but it's always advisable. Please join these lines. It's always advisable that you're on the group and check the messages on the WhatsApp group, because we'll drop a lot of information there. Right? So that's Armstrong and Bessie. Thanks for your question. We move on. All right. So this person says, Osarogi says that can we share the slide? I don't think there's anything spectacular in this slide, bro. If you want it, I can drop it on the group. That's no problem at all. All right. So Alua, oh my God, who's drawing this? Alua Tanubari Goswell. I'm sorry if I killed your name, but you said it's AI available in engineering. Definitely. It's like the first place where you find AI. So it depends on the engineering you're talking about. Engineering is wide. Okay. But when you come to mechanical engineering, you have AI incorporated in robotics, right? So robots can determine whether or not you can, or whether or not to pick this based on its texture, or to pick this, to know what this is, and all of this stuff. So you can impute computer vision in robotics. You also have self-driving cars. You have it in anything, agric engineering, like I mentioned, you have it in agric, in anywhere. But if you want more information, just type AI in engineering, and then you'll be blown away by the mammoths knowledge you get if you type that on Google. Someone was saying an audio if possible. I don't know what that means. I don't know. You're not getting my audio? So set P breaks. I'm also human and I didn't move out of my seat. I think it's just about you trying to take as much water, I don't know, before the class. Because I really don't think we have that. While I was in school, we used to have 2 hours class, 2 hours classes. And then people got to use themselves. So anyway, most of the time we sit back and then sit in one position for 2 hours. So I don't think it should be a big deal. Okay, so Olaoye Boluwatife says that please, how do we get the slide? If I'm going to send it, I'm going to send it through the WhatsApp platform. So please join the WhatsApp platform. It's very important. Okay, so Alua, I'm not going to mention your full name because I don't want to kill it this time. So he said, what's the full meaning of KPI? It means key performance indicators. So that's the meaning of KPI, key performance indicators. It's just what you're checking, okay? What you're using as your yardstick to check your success or failure. Yeah, that's what they call it. So can we get a PowerPoint file? Yeah, a lot of people are asking this, Chica. Yeah, so you should get it. Okay, so you sent a personal visit to me, but I don't think it's personal. He said, how long will the classes last? So it's 2 hours. It should be for 2 hours. So tonight, definitely won't use up to 2 hours, but it should be for 2 hours. Okay, so can we get the recording of this evening's class? That is still under deliberation, but if you're getting it, which you may, we'll upload it to our YouTube channel. So that's Alo-Fusion's YouTube channel. You can subscribe to our YouTube channel so you don't miss out when we upload the video. All right, so how can one really study AI? Read, practice, that's all I can say. Yeah, read and practice. Going forward, I'm going to give you a couple of textbooks you can read. I can give you blogs. You can also read fantastic blog. I've gained a lot from them. I can also give you YouTube channels to check out, and then I think you'll be good. Yeah, so he said with particular emphasis on AI in law. I'm sure you're studying law, you're a lawyer. Interestingly, AI would have its applications in law. It has its application in law already. You can check online, but I'm sure AI will be used for it will help to improve how lawyers interact with cases. So AI can do all the dirty work by trying to get previous related cases, analyze the cases, see the points the lawyer used, and predict the outcome based on that point. So the AI can know, if you go this route, this is how it went the last time. So don't bring up these points in your court of law. Don't say this, don't say that. That lawyer said it and he lost his case. So you don't say it. So that's just I was saying that as a light joke, but on a very serious note, yes, AI can be used to do analysis of previous cases, and it can also help guide the lawyer's decision in future cases by predicting how the cases will end based on the situation of things. All right, so okay, Chika, I said you didn't get different between testing and training data. You will definitely get it in the course of this tutorial because we'll talk about it a lot. But as I was saying, the idea of training and testing is you have your data, all your data are labeled first of all right? You have a complete labeled data. Features are like the things, I'll call them questions, and then labels are your answers, all right? So when I'm training my data first, I'll expose both questions and answers to the machine learning model, okay? So then I'll train the data. Okay, so when I'm testing the data, I'm passing only the questions to the model and telling the model to predict the answers. Okay, so I'm hiding the answers from the model. All right. So after the machine learning model has predicted its own answer, I'll now compare that answer to the real answer from the data. Okay, so that's called model evaluation. All right. So I'm comparing the answers to just see how right or wrong the machine learning model has performed. Okay, what aspect in mathematics do you love? It's just basically linear algebra, um, statistics, definitely statistics, and maybe you're doing calculus basically, except you don't start creating your models. But yeah, with algebra and statistics, you're good. But you may never need it. It's just to understand how these algorithms are built. Okay, so can we get a recorded of meeting? I think I was that. So did you record your audios for like a podcast, especially if people are not able to make a particular class? Okay. Oh, well, Sarogi, thanks for the kind words. It's very informative. Yeah, thank you. Concerning the podcast, yeah, definitely, because I'm recording this class, I will have the audio file. So, like I said, it's just better for everything to be on YouTube, and so everybody can get it when it's there. So let me scroll down. It said, can we download resources for, I think you didn't complete your question, Oluwatu Fumi Akinwale. Well, I think I didn't get your question, so I can't answer. So how do we use it? Machine learning in real world? Oh my God, it's everywhere. I was saying it, right? Social media, YouTube, everywhere. YouTube uses to, recommend videos for you. Netflix, when you're watching videos on Netflix, how is it possible that Netflix gives you a video that you most likely not turn your eyes away from? They'll give you tailor-suited recommendations, okay? That's AI. AI it's in real-world situation. You have self-driving cars, okay? It's everywhere. Tesla, they have self-driving cars now, all right? And so it's actually in real-world situations. Machine learning is everywhere. Machine learning is what powers this AI system. I think maybe you're confused between AI and machine learning, all right? Machine learning is what powers AI system, all right? So machine learning is like you're building the engine that can now incorporate into real life situations, and then you can say, oh, this system is artificially intelligent, or this is an artificial intelligent system, whatever. Right? So yeah, which machine learning tool is recommended in electrical? I'm not conversant with electrical engineering field, but it has a very massive, correlation, because when it comes to AI, you also have to deal with sensors. For instance, I talked about self-driving cars. So you have to do with cameras to get input data, right? And all of the stuff. When you're talking about robotics, you need sensors to also identify, oh, there's an object here, there's no object here, all of the stuff. So yeah, I think I'm getting exhausted. The questions are tiring, but let me just answer maybe one more. Okay. Someone sends me past that message. So Olade, yeah, you can get in touch with me, no problem. All right. So okay, please example application of supervised, unsupervised, and enforced. Yeah, I think I said that already. Okay, so what I mean by supervised, unsupervised, and reinforced are the way the models were trained. So it all boils down to the kind of data you're receiving. So if the data is labeled, that model is definitely going to be a supervised learning model. If the data, if the data is not labeled, it has to be an unsupervised learning model. So when it comes to YouTube recommendations, where they create clusters of people, for instance, one of the things YouTube uses is to create what we call collaborative filtering. So if I am 10 years old, I live in Lagos, and then I spend 2 hours on YouTube every day, and I watched Mr. Macaroni's video and I liked it. It therefore means that someone that is also 10 years old, live in Lagos, or maybe not where I am exactly, and we have common features. YouTube recommend that video for him. How did YouTube do that? YouTube cluster people based on their property. Okay, so if this guy, has this feature, and that guy that has that same feature, all right, would like what this guy has liked, and that's called collaborative filtering. In a way, it's an unsupervised learning, because YouTube doesn't. It's not like YouTube knows me per se. They're just clustering based on our features. So in a nutshell, wherever you see clusters, okay, wherever you see clustering, K means clustering, whatever clustering, that is unsupervised learning, okay? But whenever you're seeing data that has label, for instance, I want to build a model to classify a cat and a dog. I'll feed the model with a lot of data with, okay, this is a cat, or this is a dog, or this is a cat, this is a dog. And after a while, I'll tell the model, oh, now classify on your own. What is this without the label, okay? That's unsupervised learning, so in computer vision and all of the stuff. So why reinforced learning was in the AlphaGo stuff I told you about, creating a game that learned over time and beats the world best. Okay, so you can read about AlphaGo, AlphaZero, all those things. You can just read about DeepMind. Okay, just type Google DeepMind, and then it's a company by Google that works with AI systems, and then they create models to better AI. All right, so Peter Bartunde, he said with vast array of data, is it not possible to get strong AI? Yeah, you would, but it's not just about the data. The data is never enough. You're saying with the vast array of data. Do you know the amount of data you have in a day? The amount of data you produce in a day? Billions of data produced every day. Not, in fact, every second. So it's difficult to create models that can do anything outside of the box, or that can behave exactly like humans, okay? Or that can have minds on their own. There's a lot of things to be done, a lot of things. So it's not something you get in the next 10 years. It's not something you get in the next 20 years. Even in the next 50 years, it's not assured, all right? So I don't think that will happen. Okay, so I guess, okay, let me just answer one more question from, I'm sorry if I have skipped some questions because I think this guy just went to the last thing on its own. So if I skipped your question, really sorry, really sorry. But let me answer this question from Glory. So you said, what about working engines with pre-programmed assets? So different programs can be created. Do I understand that question? I'm sorry, I do not understand. What are we working? You said working with machines. What about working? Are you responding to something I've said before? Because it looks as though you're responding to something I've said before, which I don't know. I don't know. So what about working with machines with pre-programmed? I'm sorry, I didn't get that. You can send me a personal message, Glory, and then we'll discuss. So guys, if you actually have problems, I don't know, I hope I won't be overwhelmed, but you can send me personal messages on WhatsApp. If I'm not overwhelmed, I'll respond to you, definitely. So that'll be all for now. And then I will see you guys in the next one. All right, so before I go, someone was saying on the group if this will be free. Well, it will be free, it will be free. I'm just one that I feel, okay, with what I've got, I think I can share my knowledge with people and help improve people's life. But if at the end of the day you feel we deserve something, I don't know, Alo teammates can create a platform where you give us a tip. That's possible. If you think you got value from this program, but that's not under any form of compulsion. It's just completely, it's meant to be free. But if you want to do something, I think the team would work around creating a platform where you can give us a tip. So yeah, it'll be free, give you my time, everything. And then it's just to make a world a better place, really. Create people that would, of course, make the world a better place. We have to move fast. The world is moving fast and we have to move along. All right? Yeah, so thank you all for your time.